All right, so I think this is recording. Let's take a look at three problems here, absolute value equations. And this time notice that there's a variable on the outside of the absolute value symbol, so we have to make sure that we check for extraneous solutions on these problems. So let's come over here on number 13. We have that this 2x plus 5 could represent the opposite of 3x plus 4, or that 2x plus 5 represents that 3x plus 4 exactly. So let's solve each one of these equations for x by getting x by itself. So here we've got 2x plus 5 negative 3x minus 4. If we add 3x to each side, if we subtract 5 from each side, and if we divide by 5, now we need to check and see if this is if this checks or not, if it's extraneous. On the right hand side, if we take 3 times negative 9/5 plus 4, then I have negative 27 over 5, and I'll rewrite 4 as 20 divided by 5, and you can see that this is a negative number. Well, how could an absolute value ever equal a negative number? The smallest it could ever be is 0. The absolute value of any number is either 0 or positive. So this answer is extraneous. Let's check this other one and see if it works. Let's subtract 2x from each side. Subtract 4 from each side. We have that x is equal to 1. On the left-hand side, if we plug in 1, we've got 2 times 1 plus 5, which is 7. And the absolute value of 7 is 7. Well, the question is, when we plug in 1 over here, do we get 7? And you can see that we do. That this does check, and the x equals 1 is our only solution. All right. It's still getting used to this software. All right, so let's take a look now at number 14. All right, so we've got that 2x plus 12 could be the opposite of 4x, or that 2x plus 12 is equal to 4x. So if we add 4x to each side, if we subtract 12 from each side, if we divide each side by 6, we get negative 2. But we can see immediately that this is going to be extraneous. On the right-hand side, you've got 4 times negative 2, which is negative 8, and an absolute value is never going to equal a negative value. It's only going to equal 0 or positive. So this one is clearly extraneous. Let's move on to this other equation. Let's subtract 2x from each side, divide by 2, and we have that x is equal to 6. So on the left-hand side of the equation, we've got 2 times 6, which is 12, plus 12. Hey, that's 24, and the absolute value of 24 is 24. Of question is, on the right-hand side, do we also get 24? And we do. So we have that this solution satisfies this equation. It makes it a true statement. So there's our answer for number 14. So let's take a look at this last one. We have this 9 minus 2x, and that could equal the opposite of 10 plus 3x. Or we could have this 9 minus 2x is equal to 10 plus 3x. So we want to step by step get the variable by itself. Let's add 3x to each side. Subtract 9 from each side. We have a possible solution of negative 19. But when we plug in the negative 19 on the left-hand side, you can see that 10 plus 3 times negative 19 is going to be a negative number. So this is clearly extraneous. What about the other equation? Let's add 2x to each side. Subtract 10 from each side. Divide each side by 5. We have a possible solution of negative 1/5. So let's plug this in and check and see what we have. On the left-hand side, if I get a common denominator of 5, I can rewrite 10 as 50 divided by 5. And I have 47 over 5. Well, on the right-hand side, I have the absolute value of 9 minus 2 times a negative 1/5. I've got, let's get a common denominator of 5. And you can see that we have 47 over 5 is equal to 47 over 5. So this does check, and this is our solution. So hey, I hope these 3 problems help, and I'll talk to you later.